Hello and welcome to section 11.3. Here are the answers for 11.2, day 2. Today we're going to be solving radical equations. I like this topic. It's a little bit easier, in my opinion, than 11.2. It's good because it's a little more straightforward. There's kind of almost always one way to solve these questions here. So what we're going to be doing is we're going to be isolating whatever's underneath the square root part. So you're going to get rid of anything but the square root, just like you normally would when you're solving an equation, and then you're going to square both sides. So isolate the radical, square both sides. So that means if I have like 2x minus 3 plus 5 equals 7, whatever, just making up a problem here, you got to get rid of this and you got to get rid of that first. This is what you're trying to isolate, whatever's underneath that square root. Alright, so let's just jump into some examples here. I'm going to add 8 on both sides. So what I'm going to do is I'm going to isolate the square root of x by getting rid of that 8 and the 2. So you have 2 root x equals 8, divide by 2, and you end up with 4, and then square both sides, x equals 16. And you can double check your answer. 2 root 16 minus 8, does that equal 0? So 2 times 4 minus 8 equals 0, that works. 8 minus 8 is 0. So you can always check your answers, which is very important here. This one here, we're just going to add 7 to both sides, square both sides. That's a nice and quick one there. This one I'm going to add 3 to both sides, and then divide by 12, and get 1/4. And then I'm going to square both sides. The square root, or sorry, 1/4 times 1/4 is 1/16. There you go. Okay, this one is just like before, except for now we have the square root of x minus 7. So what we're going to get that part by itself. So I'm going to start by subtracting 12, and that leaves me with 16. And then I'm going to divide by 4. That leaves me with 4, and then I'm going to square both sides. And then I'm going to add 7 after I'm done squaring both sides. So 23. And again, you can check your answer by plugging it in. 4, and then 23 minus 7 plus 12. Okay, so 23 minus 7 is 16. Square root of 16 is 4. 4 times 4 is 16. 16 plus 12 equals 28. So that does work. Now this is an example where you have radicals on both sides. When you have radicals on both sides, you just get to square both sides and they're just gone. It's nice and easy. Subtract the x to get 2x, add the 17 to get 38, divide by 2 to get 19. So, and then again, you can plug in your answer to make sure that it works. But those are nice and simple actually, even though they look kind of complicated. What I'm going to do here is I'm making number 4. This one's a little bit different because you have a square root minus a square root. You're going to add the square root to the other side. And then what you can do is you can square both sides. So don't square both sides until you move it to the other side, because they'll affect your negatives, and it's actually not mathematically correct to square both sides from the start. It actually turns into a mess. If you try to square this part right here, if you try to square that, you get a disaster. So don't do that. Let me erase that. Okay, and then I'm going to subtract the x to get 3x. And then I'm going to add the 3 and divide by 3, so x equals 1. Okay, now we get into some extraneous solutions. What that means is when you get a solution that works, but it doesn't actually work. So I'm going to explain what that means. Generally what happens is when you have an equation that looks like this, so to get rid of this square root sign, I square both sides. And what that does is it gives me a quadratic equation. So I'm going to move everything to the right-hand side by adding the x and subtracting the 6. going back to quadratics, I can factor this really easily. X minus 2x plus 3. So again, we're using our stuff from chapter 9. As I mentioned, we're going to be using it the rest of this year. Now those are our two solutions, 2 and negative 3. When I plug in 2, 6 minus 2, square root of 4 equals 2 equals 2, 2 equals 2. That one works just fine. But when I plug in negative 3, the square root of 6 minus negative 3, does that equal negative 3? No, you can't square root a number and get a negative number. So this doesn't work. So this is why it's important to check your answers, because you're going to end up with extraneous solutions, what they're called there. So 2 works, negative 3 doesn't work. Sometimes both x's work. So don't think that, well, there's 2 answers, one of them's not going to work. Don't necessarily think that. So here's another example. Square both sides. 3x plus 4 equals x squared. Bring everything over to the x squared side. And factor this. X minus 4, x plus 1. 2 solutions are x equals 4, x equals negative 1. And then when I plug in the negative 1, you have the square root of whatever equals negative 1. This does not work, so we throw that out. When we plug in 4, square root of 16 equals 4, that one does work. So generally it's the negative 1 that doesn't work, but you're just going to have to check those out. I'm going to skip that. Here's your assignment. Let me know if you guys have any questions. Thank you for tuning in, and like I said, just let me know if you have questions, and we'll go from there. Thank you.